Okay, this is about a quadratic problem that was done many, many years ago, thousands of years ago. There are Babylonian mathematicians, and they did this special thing. They didn't have algebra. They thought about the problem in words and pictures. Okay, so they started with a square plot of land. They wouldn't have an X here. It would more sort of be a question mark in their mind. Then there was another plot of land, and we don't know what it is. It's something unknown, but it's times 6 units this way. But they knew that the sum of these two things, they wanted to be 16 square units. So it was sort of an equation. Well, it was exactly an equation. Well, the first thing they did visually is they took the square and they took this rectangle x by 6 and they stuck them together. Because they're both x, then they just fit, that x would fit there. Now we know we use algebra to go x times x is x squared. They would know that the two sides were multiplying to equal the area they didn't know. They would know that this 6 times the unknown, that's what would be here. But we can use algebra. We go 6 times x to give you 6x. So they did stick the two shapes together. We know this. We're looking at these clay tablets. Okay. Now they knew that this rectangular piece of land here needed to add up to 16. We're going to do some algebra though with it. So we take the x times x plus 6, and we see we get x squared plus 6x. We need this equation here, x squared plus 6x equals 16. They just have an equation in their mind. But then they did something special with this thing. They did something really weird. It's called completing the square, but this is what they did. They take this length of 6 and they cut it in half. Instead of 6, they make a line of 3 here. And then they make a line of 3. They go x, a line of 3 here. So they split the 6 into two parts, a 3 here and a 3 here. Now what they've done is created a square. It's x plus 3 this way and x plus 3 this way. Well, an x plus 3 squared, the whole thing is a square. But gee, x plus 3 times x plus 3, these 4 boxes, it's really like foil. X times x is x squared. And then this x times 3 is 3x. And then x times this 3, is 3x. And then something special happens. This box right here down in the bottom, you see this length here must be 3 because it's 3 at the top. And this length right here must be 3 because right beside it it's 3. Well, then 3 times 3, that makes this new little square in here 9 square units. And that's what they did. By creating this x plus 3, they created a new little square here. And we know the area of it, though. It's 9 square units. Now they made, in a picture, they kind of made something new. We're going to use algebra. We ended up adding 9. When we completed the square, we add 9. And we're going to put it in our equation. And whatever we do to one side, we do the same to the other. So we add 9 to the 16. But hey, we know that x plus 3 times x plus 3 really equals this x squared plus 6x plus 9. So that means x plus 3 squared must equal 16 plus, it must equal 25. And now the Babylonians were good at taking square roots. And we know how to do that too. The square root of 25 is 5 because 5 times 5 is 25. And the square root of x plus 3 squared is just x plus 3. When you take the square root of a square, it just cancels. And now you've got a really easy equation to solve. It's must be 2 because 2 plus 3 is 5. Take away 3 from both sides. Well, these numbers are easy, but they actually did it with really hard numbers. They completed the square and were able to solve more complicated problems. But now we can go back to our original question, and we know what this little square at the end is. It must be 2 by 2. And what does it add up to 16? I think it does, because it's 2 times 2 plus 8 is 2 plus 6 is 8. 2 times 8 is 16 square meters. So that solves the problem we were trying to do in the first place. Now, we're going to do an exercise. You have to create, with new numbers, you have to create all these steps yourself. It's a little bit challenging, but I think you guys can all do it. You've got the video, you've got the example in notes. I think you'll be able to do this question here. It's exactly the same same question, a square plot of land added to another plot of land. But now, instead of the length being 6, it's 12. Instead of adding up to 16, it's 64. You have to do all these steps, just like I did in the example. There's the marks. It's going to be an exercise out of 14, and I think we're going to count it for something, so we want you to really try. Well, that's the end of this video now. Hopefully it helps. Hopefully we can do it. So just do your best. Okay.